Hi everybody. So in this video, we're going to look at the determinant of a square matrix. So we have matrix A, which is this 2 by 2 matrix here. The elements are A, B, C, and D. We say the determinant of matrix A is equal to this symbol here, where A is between two straight lines, and this is equal to the difference between the product of the elements A and D and the product of B and C. And our determinant allows us to find the inverse of a square matrix. If the determinant of A is equal to 0, then A is what's called a singular matrix, and it does not have an inverse. But if the determinant of A does not equal 0, then A is what's called a non-singular matrix, and it does have an inverse. So in example A, we've been given this 2 by 2 matrix, and we've been asked to work out its determinant. So we're going to use this formula here, where this would be our A, B, C, and D value. So if we say this is matrix M, well then the determinant of M will be equal to the product of the 2 and 3 minus the product of the 4 and the 5. So we'll have the 6, take away the 20, this will have a determinant of negative 14. So this matrix would have an inverse. And in the next video, I'm going to show you how to find an inverse of a matrix. In this video, we're just looking at the determinants. Okay, so for part 2, if we call this matrix matrix N, then the determinant of N will equal the product of the 4x and the negative 2 minus the product of the 3 and the negative x. So this would be negative 8x minus the negative 3x. So this would become negative 8x. This becomes positive 3x. So the determinant is negative 5x. Okay? Then for part B, show that this matrix is singular. Well, if it's singular, it means the determinant, let's say this is matrix P, of P will equal 0. So we'll have the product of the 3 and the 8. So we'll have 24 minus the product of the 4 and the 6. And you can see it is singular because its determinant is 0. Okay, let's try another example. Okay, so in this example, we've been asked to work out the value of A if this matrix is singular. So because it's singular, we know the A minus 3 multiplied by the 5 minus 2A minus the A minus 10 multiplied by 12 will equal 0. So now we can set up a quadratic equation. We'll expand out these brackets. So 5A minus the 2A squared minus the 15 plus the 6A minus the 12A minus 120. We'll tidy up this left-hand side. So we get 5A add 6A minus the 2A squared minus the 15. We'll expand out this bracket, negative 12A, and then plus 120. So now because the coefficient of the A squared term is negative, I'm going to move all these signs to the right-hand side. So 0 will equal 2A squared. This negative 1A becomes positive A, and this positive 105 becomes a negative. Then we can solve this equation. So we get 2A plus 15 multiplied by A minus 7. So our A values are negative 15 over 2 and positive 7. Okay?